All right, everyone. So in the last lecture, you learned that how you can store the token in local storage on the client side on the React app. And we stored it in local storage. We saw it using the Chrome browser application tab, and we found out that the token was saved successfully. Great. Now let's move on to the server side. So I'm back again into my Node application, and we want to create a route that will allow us to get us all of our accounts. Now, again, the accounts will be a constant hard-coded array that I have already created right there. So how should we get the accounts for a particular user? Well, there are many different ways. We can send in the username and get the accounts. But this particular route, which is accounts route, is a protected route, meaning you need to be logged in order to access the accounts. So I shouldn't just be doing something like this. I mean, I can go and say response.json and I can send all the accounts. But as you can see that this particular route is not really checking anything. I mean, if you go ahead to this particular route and ask for accounts, it is going to give me all the accounts. And we can check it out. Let's go to the Postman, and I'm going to go ahead and create a new tab, and I will ask for all the accounts. And I get all the accounts. I'm not even logged in, and I get all the accounts. So this is not good. Another thing is that, first of all, it's telling me or giving me all the accounts. And maybe I'm not John Doe, maybe I'm Mary Doe, or maybe I'm not Mary, I'm John. So we need to find a certain way to send in the username. That's the first thing. The second thing is that we need to find out that if Mary or John or whoever, if they have been authenticated successfully. And the way that we will find out that if they have been authenticated successfully is we are going to check for this token in the headers. So anytime anyone wants to access accounts or any other protected resource, like updating a profile, transferring funds, withdrawing, depositing, all of these requires login, right? So all of them have to be, the client needs to be sending the token. The token is the only thing that is making sure that the client is actually logged in, that the user is successfully logged in. So we need to find out how to send the token. We also need to find out whose account are we fetching. So let's go back. And let's say that we are fetching an account passing the username in the body. So I can go ahead and probably I can do something like request.body.username. Using the username that was passed in the body, now I can get all the accounts. So I can say over here, constant user accounts, which is an array, which we declared right over here. It only contains 3 accounts anyways. Accounts.filter an account where account.username is equals to username. So this filter operation is going to give us all the accounts based on the username that you're passing. And now we can go ahead and return user accounts. Let's go ahead and run this. This time I need to go to the body tab and I need to pass in username because we are extracting it on the server side. John Doe. Okay, so right now you can see that it is telling us that there are no accounts. So maybe we made some sort of a mistake over here. So let's go ahead and fix that mistake. Let's go ahead and check back on our request, and you can see that we are not really passing any headers. So that might be it. Let's go ahead and add our content type, application JSON. And now we get the accounts, but we only get the account for the user John Doe, because that is what we're passing in the body. If I change this to Mary Doe, I should probably get one account. So it looks like this is working fine. But still, I mean, you can know my username and I can know your username. So just because I'm passing a correct username does not really mean that the person is actually successfully authenticated. The only way we will know that the person is authenticated if the person is passing the token in the headers. This is the JSON web token. And we are not really passing anything, at least not the token, in the headers. So let's go ahead and pass in the token. We will go ahead and say authorization. That's the header that we are interested in. We will create the token by using bearer space, and then we will just copy paste the token over here with a space in between. Now, just by passing the correct token doesn't really mean that you are authenticated. It is the server who needs to grab this token, decode this token, and verify this token. But as you can see, the server is not really doing any of that stuff. So let's go ahead and do that. The first thing we need to do is we need to get the headers. And we're going to do it in step by step. So request.headers. Let's go ahead and print out, just to make sure that you are getting the headers. It's always a good idea to take this into small steps because we want to make sure that we are getting everything we need. Let's go ahead and perform a request. And since our server is running, it should be able to give us all the headers because we're printing out all the headers. We need the authorization header. So let's go ahead and get authorization header. We can pass in authorization over here. And we can call it auth headers. Now let's go ahead and print out. We're just trying to see if we can even access the authorization header or not. Again, I'm going to send the request. And it looks like we can because we are able to print out the bearer and the token. Great. So if we have access to the authorization header, and it's not undefined, then we need to do something. We need to get the token out of this header. The header is basically two words, bearer, space, and then the token. We don't really care about the word bearer. It's just there so that when the requests are going through in the network, we can quickly point out, oh, this is a JSON web token. But bearer doesn't really hold any value in what we're trying to do. What we need is really, we need the token. So we can take the authorization header and we can perform a split function on it. Let's go ahead and see what happens when we do a split on a string. Let's go ahead and make the request. Okay, so that didn't do much. It created an array with one element, and that element is a string. So split function is used to create an array. But what if we split using a space? Let's go ahead and run that again. Well, maybe we need to pass it like this. Let's go ahead and do that. And let's not print this out. So there's a space in between. Make sure that you have a space in between. I think I was just printing out some wrong stuff, but here we go, space. So what split has actually done is that it has created an array with two elements based on the space between bearer space token, and each of the string is now an individual entry in the array. So this entry is at 0 index and the token is on 1 index. All right, so let's go ahead and get that part. So I'm going to go and we can check multiple different ways. So let's say that if we say over here, let token equals to auth header dot split, and then give us the location number 1. And we can go ahead and perform console.log, because on location number 1 or item number 1 on the array is the actual token. Let's go ahead and do that. And we get the actual token. That's good. Once we get the token, we need to verify it. Verify the token. The reason we need to verify is we need to make sure that this is the same exact token that was given to the client and nobody has tampered with the token. There are different ways of verifying. We can use jwt.verify, passing in the token and passing in the secret key, which we use secret key when we are signing the token. So it has to be the same secret key. We will get the decoded token. Now let's go ahead and print out the value of this decoded token. Let's go ahead and send the request again for accounts. And you can see that the decoded token is giving you the username because when you sign the token, that's what you put inside the token, which is right there. You put in the username in the token. So when you decode the token, that's what you get back. Once again, do not try to put any sensitive data into the token. It can be decoded. So make sure that you are not putting social security number, credit card, debit card number, passport numbers, driver license numbers, and these kind of things. Once we have the decoded token, we can check, first of all, if it is successfully decoded. If it is decoded, we will go ahead and get the username out of there. Once we have the username, we need to make sure that this username actually exists in our database. Now, we don't really have a database, but we do have a users array that is acting like a database. So we will have to find out that if this username actually exists in the database or not. So users.find user, where user.username is equals to username. And we will say persisted user. If persisted user exists, which basically means that the user actually does exist in the database, then we can take some action. Else, we can do something else. So what do we want to do if the user actually does exist? So this is the verification step, meaning we have already verified that the token is good, and we have decoded the token, we got the username, we have already checked that the username or the user already exists in the database. The next step for us would be we can use this username, or we can get the username from the body, and we can perform a filtered request. So I can go ahead and perhaps I can simply use the accounts.filter over here, pass in the persisted user.username. This will give us the user accounts, and then we can say response.json user accounts. So in this scenario, we don't really even have to pass in anything in the body because we are using the token and we are decoding the token to get that value. Now, this is up for discussion. I mean, if you want to pass in the actual value in the body, that is perfectly fine. It's not like a right or wrong thing. I mean, I can go ahead and get the value from the username, request.body.username. That is also fine. So if you want to do that, that is also fine. Because you may not be putting username in the token itself. You might be putting user ID, or all of this code might be somewhere else, which we will see later on. All right, so this looks good. Let's go ahead and try it out, even though we have a couple of different cases that we didn't handle. What if the user does not exist? That's the case for that. Then we have a else case for what if the decoding fails? And what if there are no authentication headers? What happens in those scenarios? Let's go ahead and try to do a perfect scenario in which we are sending in the authorization token and we are sending in something in the body. So over here in the body, I'm sending username, which is John Doe. And in the headers, I am sending the correct token. And you can see that I'm able to get the correct results, the account for John Doe. Now, if I don't send the authorization token, I'm just going to uncheck it. It kind of fails. You can see that it's not really doing anything. The reason is that we didn't really handle that case. Right over here, when we are not sending any authorization header or no authentication headers were found because you're not even sending it, then we should do something about it. For the no authentication headers, we can perform a status, and we can set the status just to let the client know that it is the authentication or unauthorized client. And we can even send some sort of a JSON back if you want, which can be no headers found, or no authentication headers found, or authorization headers. Let's go ahead and run this. And now you can see that if you don't send the authorization header, then you get the message, no authorization headers found. What about if the user doesn't exist? Well, if the user doesn't exist, then we can also send something back. You can say success, false, message, user does not exist. And over here, we can also send success false, just to keep it same. What if the decoding actually fails? Well, in that case, probably you have tampered with the token, so we're just going to send that back also. Now, what about the scenario where you are sending the correct username, but somebody has tampered with the token? Tampered means that somebody has changed the token. What's going to happen then? Well, I'm going to go to the authorization. I'm just going to double click it and just change one single character over here, E2Y instead of EY. Let's go ahead and send it. And you get this very large error saying invalid token. The user doesn't really want to see this page. The user, the client, just want to get some sort of a JSON response that the token is invalid or the token has been tampered with. So this is not good. Let's go ahead and change this. So what's happening is that when you tamper with the token and when you try to verify the token after it has been tampered, it has been changed, altered, then this verify line, the function, actually throws an error. What we can do is we can mark this with try and catch. So let's go ahead and start wrapping this with try block as well as catch, which is exception handling in JavaScript. Now I'm going to go ahead and right click and say format document, so everything is nice. So since now the jwt.verify function, which can actually throw an error if the token is invalid, is inside the try and catch block, if it throws an error, instead of blowing up, it's just going to go right there to the cache. And that is our opportunity to return to the client or to send some sort of a message to the client. So I can go ahead and print any message I want. I'm just going to go ahead and say token has been tampered, meaning that you have changed the token or somebody else has changed the token. After doing that, let's go ahead and make the request, making sure that we have tampered with the token. You can see right there that I have added 2. And now instead of getting that long error, which was in HTML format, I am getting an error saying success false and message its token has been tampered. And this is something that the client can consume and display on their screen. So even though you aren't sending a token, you tampered with it, only one digit, one item, one character, it is not working. Now if I sending the correct token again, it is start working again. Cool? Okay, so this looks like it's working. What about if we want the same functionality, meaning we have another route, let's say post, and I'm saying deposit the money. So I have another route, a post route, and that route allows me to deposit money to my checking account or my savings account. Now this particular route is also a protected route, meaning in order to perform the deposit or withdraw action or deposit action, I need to first check that are you sending the authorization token? Are you the token verified? Do you have a username? Can I go ahead and find you in the database? So I have to do all of those different things again because this is a protected route also. You have to be authenticated in order to deposit money to the checking account or savings account. So what do you think I should do? I should probably copy all of this stuff, right? I mean, because I have to do all of this stuff anyways. But that's a lot of copy pasting. So maybe there is a different way to organize this code. Maybe we can take help from middlewares. So let's go ahead. In the next lecture, we will learn that how we can move all of this authentication code into a middleware.